Okay, so let's talk about functional interfaces and Lambda in Java 8. It's one of the unique things that's been added to Java 8 that really changes the syntax in kind of a interesting way. Let's have a look at it. Java 8 functional interfaces, what they are. So functional interfaces and Lambda has been added pretty much the same time to support each other, and they have both been added to support the stream API, which we will see later. Now, as we know, Java is an object-oriented language, so it does not support function as a first-class citizen, or it does not support a function individually. A function has to be wrapped inside an object, and that causes a lot of issues if we do not want the verbose, the boilerplate code of the object. For example, here we have a runnable interface with a method, and this all we need to do is run this method, but we need to add so much code about creating an object, a class around it, all of this because it has to be wrapped inside an object. So Lambda removes all of them, and it does it through functional interfaces. So let me first see what functional interface is. A functional interface is basically just a regular interface with an optional annotation called @functional interface. This is optional actually, but once you add it, and if interface to an interface, the interface has to be a functional interface, or else we will get a compilation error. Let's see what a functional interface is. A functional interface is basically a function that is in Java. A functional interface is basically an interface with one method, one abstract method allowed. It can have a lot of static methods, default methods, but it can only have one abstract method in that function, in that interface, which we call a function. A lot of default interfaces have been given to allow us to use them. Some of them are consumer, supplier, function, and predicate. Let's have a look at how functional interface, which are functional interfaces. So this is an interesting code that talks about what is a functional interface and which one is a functional interface. Let's look here. Interface foo. This one is not a functional interface because this method is basically has the same signature as the parent object class, and therefore it is not an abstract method. This interface does not have any abstract method, so it cannot be a functional interface. If I actually put an functional interface here, I'll get a compilation error. This one is a functional interface because int compare is an abstract method, and equals, as we discussed earlier, does not count. Let's look at this. This is interesting. Here we can think that object clone will be a functional will be a object method, therefore m is an abstract method, therefore this should be a functional interface, but it is not, because object clone is treated as an abstract method here, and if object clone is treated as an abstract method, we have two abstract methods in this interface, which violates the condition for a functional interface. That is, it should have only one abstract method. Now, why is object clone being treated as a abstract method? Because its signature does not match the object signature. Let's have a look. Go to Zeal. Let's go to object in Java, and we go to object. Perfect. Now we have clone. If we see clone here has a modifier of type protected. So for this to implement that, for this to have the same signature as that of, for this to, let's just say, override the parent, it must have the same signature and same access modifier. However, because it is an interface, it is forced to have a public access modifier. So public is not same as protected, and therefore this is not a functional interface. In fact, for the rest of this, I can actually go into the code and see I have a REPL here. You can go here, my REPLs, Java 8 features and functional interfaces. So once the REPL loads, we can see that I have actually put the code here. So we can actually see that here in this code. If I actually, so this is a functional interface. Let's go to clone. Yes. Now if I actually try to run this code, it will give me an error because I have written functional interface here, whereas this is not a functional interface. So if you see the code, we got a compilation error because of this. Remove it. Yes. And so the access modifiers are something to look out for in this case. And as we can see, it will load. Yeah, foo is not a functional interface. Multiple non-overriding abstract methods, because clone is also treated as an abstract method, right? Let's say I add protected because I want it to match the same one. Now this will have an issue. Let's have a look at that. It will have a different compilation error because clone cannot be protected, it has to be public. So yes, modifier protected not allowed here. It cannot be a modifier protected, and plus it's not a interface. I'm getting the message here finally. Illegal modifier to the interface, only public, private, abstract, default allowed. So that is the reason why this cannot be a functional interface. Let's look at this. This will work. This code will work because both methods, two methods, but they have the same signature, so they will kind of merge into one in the final interface Z, and that becomes one abstract method. Moving forward, here we again have two methods and they look different, but y.m, this is a subsignature and return type substitutable for the above one. That is, its return type is substitutable. That is, iterator string is substitutable for iterable string is substitutable for iterable, and the signature that we see, iterable string here and iterable, is a subsignature of the previous one, of x.m. So the concepts of subsignature and return type substitutable are a little complex, which I will not go into here. The Java language specification has more details, or we can Google and check them what they are. So basically these two merge into one and are treated as one in the final interface. Let's go to the next one. Add functional interface here. So this, even before I add functional interface, is showing compilation error because of generics, because no method has a subsignature of all abstract methods. Basically these two, m and m, have completely different generics, number and integer, so they cannot be merged into one. If I change this to number, you will see this issue goes away. The moment you change, you see the compilation error gone. And now this is because basically now they have become the same methods, just like the previous example. So let's go to the next one. Again we have an issue. It looks like the same, but they are not the same, and that's the main issue here. If I see the error, they have the same erasure type but do not override each other. So again, there is a difference between the previous one and this. In this one method completely acts as a subsignature of the other. In this, that's not the case. So it doesn't. It kind of looks as two different methods to the compiler, and it says nope, we cannot allow you to compile it. Here we just have a return type, which is not return type substitutable. Basically, what it means is that m is returning long, this one is returning int. That's not that these are not two same methods, so they cannot combine into one method inside Z, and therefore it's going to cause an issue in the final code. So as you can see, this comes even before the functional interface can be issued, because return types are incompatible for the inherited methods x.m and y.m. Right, both the methods are incompatible. Both define m, but with unrelated return types. So that is the issue here. We have another code here which is creating issues. Let's keep it here. Okay. So with that done, finally we have this one. So this code is going to throw compilation error, because even though these two look exactly the same, in the child one I am defining this by x and this by y, and this by x by this by y. So the final generics type of these two become different. So these two methods cannot collapse as one inside foobar. However, the same thing, I write it like this, even though these two are still the same. If I write it as x, that both of them have so basically this t and t now represent the same thing. Foobar is x. At this point, yes, at this point it will work, and it's also a functional interface if I run it, because now those two methods can collapse into one. Yes. So this is basically the fundamentals of functional interfaces. Let's go back here into the code. So this is functional interfaces. So now let's look at Lambda. What is Lambda? A Lambda expression is a way in which we can visualize a piece of code leveraging a functional interface. What does that exactly mean? It means that, for example, let's say this code, runnable r1 equal to this, whereas if you look on the code that we got above, runnable r is equal to new anonymous class and then this method. So instead of writing all of this, what we are doing is we're just writing this line, and it will convert it, it will add all of this on top of it, and it will assign it to here. So basically what this line is doing is it's taking this method. This is basically a method with no arguments and one value, only one value in the method. So it's basically taking this and converting it into a method of converting it into a method and then putting it inside a anonymous class of the type runnable, and then assigning the reference of that class to R1. So all of that work is being done by this one line. So because runnable is a functional interface, we can use a Lambda expression to create its instance. That's what we're doing here. So why do we need Lambda expression? Of course, reduce lines of code, and then we have a stream API that can take advantage of the Lambda API. This is the example that we have given here. A stream API is taking the help of a Lambda API of functional interfaces and Lambda. Using functional interfaces and Lambda, basically we can move code around. We can pass a function into a code and make it work. Earlier we had to pass objects. Even now we are actually passing a anonymous class, but while that's happening behind the scenes. While we are coding, it just seems like we are passing a method or passing a piece of code. So for example, if I look here, yeah, so if I look here, we have methods like is odd, is greater than 3, is less than 11, all of that. So let's say I have this code called is odd. I need to pass it to a code, to a method. I'm simply passing it as numbers test. This is again a method reference which will come later. Numbers test is odd. How is that working? Basically what it is doing is, when I write this method, it is expanding it into this method, putting it inside the method of an anonymous class which is implementing an interface which is compatible with this, and then passing that object into filter. So what I am actually passing into filter is an object reference, but that object reference is pointing to an anonymous class which has only one method, and that method is being implemented with this code. So instead of doing all of this, we just write this code and boom, this code and boom, say this code and boom. This is one of the all the valid ways in which anonymous lambdas are created. These will all basically be expanded into lambdas. As you can see, some return values, some do not return values. We can define a type, we may not define a type. However, this is the last 2 points are interesting, is that illegal can't modify inferred type. If you have an inferred type, we cannot put that as final, and if you have one inferred type, we cannot put the other one as a type. If you are inferring, the entire thing will be inferred and the compiler will infer it, or we can put both as strict types. So that's lambda. And we also have something called method and constructor references. Basically any method can be passed around as a code now. Again, what is actually happening is that we are not passing the method as a code, we are wrapping the method inside the method of a anonymous class, and that anonymous class is basically a child, or basically implementing an interface. All of that is completely hidden behind the curtain, and all we get to see is that we are passing the method, because at the end of the day, this method that we are passing, for example system get property, this is what that will get executed. Everything else is just a structure behind it that makes it happen within the Java way of doing things. So this might look a little cryptic, what is going on here. So for that I have this this article which is quite interesting. It says method references in Java 8, and it talks about all the method references. There are 4 types of method references in Java 8. First one is object instance method. This is the code. It's pretty interesting. The most interesting line here is this. As you can see, my interface is a functional interface, and it has one method which returns void and does not take anything. So if I have to pass this, if I have to run this method, I have to first set it. And how do I set it? My interface ref is object method interface method reference my method. What is my method? My method has the same signature as display. It doesn't take anything and it returns void. So basically it will set this method to this. Now it doesn't actually do that. What it does is it will take object my method. Okay, this code basically it will work like this. If I have to show what this line does. So what does this line do? This line basically what it does is it expands it like this. Basically we'll do new my interface. Okay, what is this doing? This is basically creating a anonymous class of the type my interface. Right now my interface has to implement void display, so it will implement void display. Okay, and we'll give it a structure, and inside that what it will do is it will call the method object my method, which it will basically call what you can say my method. Boom. This is what it will do. So if I anyway run this now, if I do ref.display, right, the code that is being shown here, ref.display, right, if I have ref.display here, what it will basically run is it will run object or my method, which is the same thing. All of this is being wrapped into this line, and that's the method inference. Let's go to the next one. Okay, so here we have a static method. The main important line here is again this multiplication multiply, right, and I am using a by function, integer 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 product. Now what does that even mean and how is it working? Again, it'll basically be the same thing. If I have to show it here, it'll basically be new by function. It has to take the generics. Okay, now we have a by function, and then the by function has a method. So if I actually see, by function is an actual interface here. See, by function is actually interface here, which has a method called apply ttuu. So basically what I'll do is, what does it return? Let's see, by function returns r, right? So it's basically that. So since we have this, we have teacher apply a b, right? So we have this, and then inside that we will call, this is a static method, multiplication. So we will call multiplication dot multiply a comma b, and it will return this. Return. Okay, all of this code right here, right, all of this code is basically this one line, multiplication multiply is being this, instead of writing this whole huge amount of code here, you know, anonymous class and all, it's like it's confusing what is going on here. This is the only line that is going on here. Instead of all of that, you just put this one line and we are done. Okay, so that's the static method reference of a static method of a class. Let's see the next one. So this is interesting. This is using an existing method. So what does this do? Again, it's the same thing. Array.sort, what does it do? Now interesting to see what is going on here. We are passing this as a parameter. How can we pass this as a parameter? We know that this will convert into a anonymous class. That means basically we are passing a reference to a class. Let's see arrays.sort. What is arrays.sort? We go to the arrays class and we open the sort method, zpqrs. So we have the sort method, and let's see what the sort take. Definitely not this. We have a string array. This one. So this is the one that it takes. It takes an array of any type and a comparator, right? It takes a comparator. So what will this do? So basically what it is doing is it is passing this one, right? It is actually getting converted into something like right? uh, Compare a anything, return string dot compare ignores case, which will take an A. Basically this is what is happening. Okay, this is what is happening in this line. So for this to work, the signature of compare and the signature of compares to ignored case should be same. Is it same? Let's check. Let's go to yes. Compares to ignores. It takes a string and returns an int. Yes, this is the signature of it, and that's what we have here. So this entire line is basically shortened into this, right? So this is how it works. And then finally, this last one is quite interesting. Last one is about method reference to a constructor. So this is the most important line here. So if I see, this is the most important line here. What the hell is going on here? Again, let's use the same philosophy that we have for now. What will this expand into? It will expand into an anonymous class. So what is an anonymous class? It will anonymous class of new my interface always. Okay, and it will implement the standard method. What's the standard method here? You are getting it from here. This is the standard method. Okay. And it will replace the implementation of the standard method with hello new. So what is going on here? What is this hello new? Hello new is nothing but the constructor of hello. So what it will do is it will return, that's the return type, it will return new hello. Okay, this is the new hello. Now of course it's a little confusing, it's not exactly the same as how we see the other method, like string compared to, it's string dot compare to. Okay, compare to ignores case is a method, new is exactly not a method, it's a keyword, but for this is a method reference to a constructor, and that's how this is done. So hello new converts into return new hello. Again, display takes a string, so this will also take a string. But does this constructor exist? Yes, it does, right here. Public hello string say, public hello string say, and it'll return that, right? And that's about it. Like, what does this return? Of course, this is a constructor, so it returns the object, so return new works. So again, you can see you can replace all of this with hello new, and this is just invoking the constructor and returning objects. This is method reference. Is pretty interesting. There are 4 types, as we saw. Object method, class method, right? Static method of the class, object method of an arbitrary object. Like method reference, basically string is a class and its method, so I can use any method I want as long as its signature is same. Finally, a constructor, hello new. So that kind of concludes the functional interfaces for Lambda and functional interfaces for Java 8. Hope that was helpful, and keep learning.